So yesterday I introduced a new topic that was introduction to cryptography and wallets, and we learned the different types of cryptography. So we learned different types of cryptography. We also defined what is cryptography, and we also saw how you can like how the encoding process or how you encrypt data in blockchain, and not in blockchain generally, but in uh, systems that really need encryptions. So like in military, you would need encryption techniques. You will use encryption. And we saw that actually the origin of cryptography was due to war. It was because of military wanted a way they can be able to like send encrypted messages to their spies, maybe, yeah. And also we saw the first cipher that was kind of created was the Caesar cipher, or yeah, Caesar cipher. Yeah, so that was the Roman Empire was way ahead in cryptography, but they used to like change the words like into 2 bits or something. Yeah, and there were some other form of encryption or cryptography whereby you use and I think most of us have seen them they use them in pictures or images, whereby somebody send you a painting, and then if you scan through that, you can be able to like know the encoding. So the before there was that scanning, there was a picture, a specific picture would be representing something, an encrypted a message or something. Yeah, and then there was the use of colors to mean different messages. Yeah, and mostly for uh yeah, in traffic lights we have different colors representing different messages. Yeah, so yeah, we also talked about the benefit or the use of cryptography, and we talked about 5 benefits of cryptography in blockchain. And that one, the first one is the avalanche effect. So we have in a slight changing in the data can result in significant different output. And then we saw the uniqueness. When you encrypt, you create a unique output for every input that you have inputted. Then we have deterministic. So any input will always have the same output if you pass it through the hash. So if passed through a hash, then we have quickness. The output can be generated in a very small amount of time. So the encryption process is actually very fast. So to encrypt, it's very easy, but to decode, it's very to decrypt the information. Sometimes it takes a lot of energy and also time. So today we will be discussing some of these what really like what actually makes cryptography a good thing when you are creating your system. And then reverse engineering is not possible. Yeah, so those are some of the things we talked about. And we also talked about asymmetric key cryptography, and I touched a bit on the crypto wallet. So there are some types of encryption that I didn't talk about because some of my notes were on my phone, and today I was able to transfer them. So today we'll take a look at the symmetric key cryptography, and then we'll do a comparison of the differences between symmetric and asymmetric cryptography. So one thing to remember is that symmetric key cryptography is the secret key cryptography, where this key has to be both parties involved in the channel all in communication share the same key. So if we are in communication with Ambrose, and Damales is the if, if if is dropping or leaves dropping. So it's a short form for ifs dropping. So yeah, Damales being the if, we when we are sending the key, normally what happens is that these keys, let me just start sharing the other slide. Yeah. So this is what I mean. So this could be me, and this could be Ambrose, or something, or someone else. And then in between here, before the keys are sent, in between here we can have a knave, or a person, or a hacker, or a software that is used to kind of hack. So we need away from my computer that we can be able to encrypt this message. And then if we encrypt this message, this is the ciphertext. Then we Ambrose will have the same key as I do have, and then he will be able to decrypt. But the problem with symmetric key cryptography is that, one, when you share this key is sent or shared in an unsecure way. So you have to like you have to like you have to like create another channel that is safe for like sending secret keys. And that's when now the military actually came up with something like pagers and telegram and such kind of tools. There was the other one. It uses the pass. Is it tempered or pass one time pass keypad or something like that. Yeah. So in symmetric key cryptography, the same key is used by the sender for encryption and the receiver for decryption. So these are the types of algorithms that are used in asymmetric. So we have the DES and 3DES. So it's a type of algorithm that you can use to encrypt your data. And yeah, so these are the advantages of symmetric cryptography, and one of them is that symmetric key cryptography is simple and also faster. But the biggest advantage is that the keys must be exchanged in a secure way. So I've actually talked about it here. So these keys are actually sent in an unsecure way. There is no way you can be able to like send this key without the Eve having to hack. And then the number of bits or the number of characters that are used to encrypt is actually easy. So there are certain letters in the English language that are almost repetitive. Like we can, they are always repeated. Like something letter E is repeated most of the time. So as you can see from this sentence, there is a lot of V's. There is a lot of V's, but something like Z, S, and something like N, some of these letters are not repeated. So a hacker can be able to like see the repeated words, and with that they can be able to like know that they can be able to like predict. You see, I think we have seen most of these movies, them doing something like that. That they are able to like the first letter is predictable, like the because of the repetitive languages. So you have to like come up with a way that those characters are not repeated, and that's what makes blockchain actually better. Because now when you do an encryption, if you combine the characters, that is the alphabets and the numerics and the symbols, you create something, so you create something unique when you do that. Because now the if or the software that is used to like decrypt this key is confused somehow, because it's not able to like now be, it cannot be able to predict which character will be in the sequence. So that is the biggest advantage. And then there is ease for hacker to get a key as it is passed in a secure way. And also it's predictable. It's easy to predict which characters will follow the other. So so this is asymmetric key cryptography, and how it's represented in and how it's represented in the, or how it's displayed in a diagram. So the same scenario, we have me being here, and then we have Bob here, and then we have so I have my own public key and my private key, and Bob has his own private and public key. So the message is encrypted and sent via the public key. But for Bob to actually decrypt it, he must have the private key to his own private key, so that he can be able to like decode the or decrypt the message. So symmetric key, we saw that a cipher uses two keys, one private key to encrypt data and one public key to decrypt data. So the advantage of asymmetric key cryptography and the difference between the asymmetric key cryptography is that so you need two different keys. That is the first one, the first biggest, the big difference. So if you look at symmetric key cryptography, both the sender and the receiver are sharing the same key. But for asymmetric key cryptography, you just need two different keys, and then user gets the key from a certificate authority. So that is the biggest difference between asymmetric and symmetric. Then the best advantage is that it's more secure, and authentication is great, because for eavesdropping, or for a hacker to be able to get into the system, he needs to be authenticated. Yeah, he needs to be authenticated so that they can kind of be able, and to get that authentication, there is no way they can be able to do that. And also this one, sending private keys, because they are generated separately, there is no need for sending those secret keys or private keys. The biggest disadvantage is actually relatively complex. So to understand asymmetric cryptography, you need to like read a lot, and also to actually practice it and also code it. You also need to practice it. And apart from that, relatively complex also means that to hack, you need powerful computers, and a powerful software that can be able to decode. So yeah, so that is the biggest disadvantage. So to one is to understand it, because it's a complex form of algorithm, and also to actually create it, it's complex because it uses a lot of techniques. And yeah, so we have the other one comparison that between the two categories of cryptography. So here we will just need the same key. Here you just need the same key to decrypt. Everybody has the same key to decrypt, but this one, you just need your own key and a platform in a way that you can be able to like send. Yeah. So asymmetric encryption uses two keys, one to encrypt the data and another key to decrypt the data. So these keys are generated together. So one is named as public key and is distributed freely. The other one is named as private key, and it is kept hidden. So both the sender and the recipient has to share their public key for encryption and has to use their private key for decryption. Just like in the case of wallets, and that's actually the reason why cryptocurrencies are called cryptocurrencies, because they are encrypted crypto. They are encrypted currencies or digit. Yeah. So we have a diagram explaining how this one is actually works. So you give out your public key to the sender, and the sender uses your public key to encrypt the plain text. And since you have the private key, the sender gives you the ciphertext so that you can encrypt it, you can decrypt it. And then the last step, you use your own private key and all passphrase, this passphrase or the seed phrase to decrypt the ciphertext. So in our case, the plain text here being the token of the cryptocurrency or the coin that which is being sent. So you give out your public address, and then I do send you some ethers, which is encrypted, or which is encrypted, and then you use your private key so that you can be able to kind of decrypt. So there is a lot of things that goes on apart from encryption, or cryptography is just a part of the blockchain technology, and yeah. So there is a lot of coding which is involved so that you are able to receive that. So if somebody who does not have the seed phrase won't be able to like claim and say that those are their own coins. So this is what make this is actually what makes the all cryptocurrency secure and safe. Yeah, because with the other forms of digital money, there is people can actually access your information. People can actually access your information, and it's easy for them to hack. So key points in asymmetric encryption that you can that is in asymmetric, there are two keys which are produced. We have the public key and then private key. So make sure that this one you get it, is that public key is used to encrypt the data, and the private key is used to decrypt the data. So these keys are generated together. So that's something that you need to note. They are generated together. They are not generated separately. Uh, if they were generated separately, then it would bring a lot of problems, because some other guys would have the same private key as mine, and others will have, yeah. So it will bring a lot of conflict. Then on the other hand, the other is named as private key, and it is kept hidden. Then we have the private key is only used for decryption and will not be shared between the senders and the receiver. So we have asymmetric key encryption algorithms. We have the RSA, we have the digital signature algorithm, and we have the Hellman algorithm. So they basically work differently. Those are types of asymmetric encryption. Then we have advantages and disadvantages of these encryptions. So the first one is that two parties don't need to have their private keys already shared in order to communicate using encryption. So you don't need to share your key. So you don't need to share your key. That's a big advantage, because if you share your key, then it means that the eavesdropper will be able to get your key. Authentication and reputation are repudiation are possible. So authentication means that you can encrypt the message with my public key, and only I can decrypt it with my private key. So non-repudiation means that you can sign the message with your private key, and I can verify that it came from you with your public key. So that's how the people are able to know that this person was the one who sent me this particular uh, amount of coins. So the other disadvantage of asymmetric encryption algorithms is that they are comparatively complex. So we had seen that, and then it's time-consuming process for encryption and decryption. So we have categories and symmetric and asymmetric key cryptography. And the first one is key used for encryption and decryption. So the first one, or the key process used, is KE, or equals KD. And then we have one. So for the keys used for encryption and decryption, we have same key is used for encryption and decryption. Then we have asymmetric key cryptography. One key is used for encryption, and another different key is used for decryption. So key processes used, we have KE equals KD. So KE, before we get back to KE and KD, let's see the speed. The speed of encryption and decryption. So the speed of encryption for symmetric is very fast, and since it's simple and it doesn't require a lot of 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 it doesn't require a lot of
algorithm.
yeah, it doesn't use a lot of letters to for encryption. But this one, since the characters and the energy used to the computing power used, or computing algorithm used, is a bit bigger, and that makes it slower. So we have the size of resulting encrypted text. So in symmetric key cryptography, sometimes it's usually same or as or less than the original clear text. But for asymmetric, the size of encrypted text is more than the original clear text size. So if you can remember from the one that I showed you about the hash function had a 64 character. It was more than the original text, and our original text was just a one word high. Yeah. But for the other one that we did, symmetric key cryptography, we actually had like one letter, or we had like five or five to normal. They sometimes they are late characters. The normal size of password, the passwords that are generated, it can be 8 characters or 10 characters. You can write a bigger password, but the password encrypted will be almost like 8 characters or something. Yeah. Then we have key agreement and exchange. It's a big program. So when you are changing the keys, so for like the key agreement is that we must come up with an agreement that this key or this particular phrase will be the one that a good example is how people say if you are in a club or a social club, like the way when we were kids, we used to like come up with some a game whereby people would say would if you found the door locked, we would have like a secret word or a word that you would normally use to, so that the like open sesame, yeah, something like that, open sesame as the key. So sometimes it becomes a disagreement because somehow you may forget the secret word, and it becomes a big problem, and the other party does not like the word, so you have to agree. And even the exchange of it, like if like open sesame, if somebody hears you say open sesame and they are not part of your group, then they will also come and use the same word, the same the same word, because the exchange is kind of like open. The key is like open. But for asymmetric key cryptography, there is no problem. So whichever word whichever word you want it to be a private key or public key, there is no problem with it. Then we have usage. So main use of this encryption is used for encryption and decryption. Cannot be used for digital signatures. Can be used for encryption, decryption, as well as for digital signatures. Its efficiency in usage. So symmetric key cryptography is often used for long messages. Asymmetric key cryptography are more efficient for short messages. Yeah, so that's the comparison uh, between symmetric key cryptography and asymmetric. So we have this other part that is on introduction on secure hash algorithm. I've basically covered secure hash algorithm 1 and how it works. But this one will kind of cover the same secure hash algorithm to five is it to five seats, yeah, to five seats, yeah, to five seats, yeah. And we'll also cover its application. Yeah. So like I mentioned yesterday that this type of algorithm was developed by the National Institute of Security and Technology alongside with the NSA. Mm, I've I've actually I don't know this one what means. I've actually said this other one. So this is National Security Agency. So I thought, yeah. So it was developed in 1993 as a secure hash algorithm, which was published as a federal information processing standard. It has different version. So I've actually said that I'll cover this one because it basically works the same as the other secure hash algorithms. So 0, 1, 2 all the way to 256. This one is normally used in blockchain. This one I think it's used in those in those federal, in encrypting federal uh, federal agencies, like the government itself, the US government itself. Yeah. So it has the following versions. So secure hash algorithm A, 0, secure algorithm 1, SHA224, SH2256, SHA512. And yeah, so secure hash algorithm 1, it works for an input message that is less than 2 to power 64 bits. The output of secure hash algorithm is a message digest of 160 bits in length. This is designed to be computational infeasible too. So to obtain the original message given, it's message digest. You have to find two messages producing the same uh, message digest. So let me just explain all this in a diagram. So you have the first step, and that the first step is panding of the bits. So you have a length of multiplied by these 512 bits, which will be the n number of words. So this is the message length, and then once it's paired, so it will be modulated, and uh, so it will kind of be converted into another a string of words of a different length. Yeah, and then after that, you like append the length of that message, and then you divide the input into 512 blocks in bits or blocks. So let me just show you another better representation. Uh, so this one is, I think this one has a better, a simpler way to explain it. So this secure hash algorithm, from what we have seen on this diagram, yeah. Uh, if you have done something called hexadecimals, hexadecimal and octodecimals, this one will be easy to understand, because different letters in hexadecimals like A represent a different hexa value, and then for B it represent a different hexa value. So this is how you are able to, like, now this is what I was talking about when you are using symmetric key cryptography, to avoid the to avoid the changing of to avoid the to avoid repeating your letters. They use these hexa values so that they can be able to come up with a hash string, with a hash string. So once you have actually done that, once you have actually initialized the chaining, or the chaining of the variables, these are the chaining of the variables now. So these variables, if it finds that there is a letter A, then this will be what will be represented once it's have been divided into these blocks of 512 bits block. So yeah, it's a long process of how these actually work, and so once the processing of brokers occurred, now the actual algorithms begins. So this is the step number 5. So copy chaining variables like AE into variables AE is then divided to current 512 bits, broke into 16 sub blocks of 32 bits. So secure hash algorithm has 4 routes, each consisting of 20 steps. Each round takes 3 inputs. So the first one is the 512 bits block. then the registered ABCD. These are the variables. And then we have a constant k, where t is equals to the number of the numbers from 0 to 79. So then in step 5, you have to the secure hash algorithm has a total of now 80 iteration. So 40 rounds multiplied by 20 iterations. Each iteration consists of the following operations. So we have the variables, which have been represented, the header variables, and then we have this process or formula to now combine them. So where these variables, these A, B, C, or header values, they register. The register made up of 5 variables. The process P, the logic operation, and then ST is the circular left shift of the 32-bit sub-block by T bits, and then we have WT, which is a 32 bits derived from the current 32-bit sub blocks, and one of the 5 addictive constants. So this one. Then so once you have been able process P in each secure hash round is round 1, 2, 3, and 4, and then this is how you now you process the process P now. And then yeah, so it's a quite complex it's a quite complex flow of how things this secure hash algorithm works, and it involves a lot of computational not computational but mathematical flow. So the value of WT are calculated as follows. We have for the first 16 words of the W, i.e. That is T equals 0 up to 15. The contents of the input message subblock become the contents of WT. For the remaining 64 values of W are divided using the equation. So this is the equation that derives the other values, that is the 64 remaining values. So this is the comparison between all the secure hash algorithm 1 and the size of the message that it carries. So this one is the 160, less 2 to 64, and the block size is 512. It's the same for the other 3, that is secure hash 25224. The name comes actually from the size of the message. This took the size of the name of the secure hash algorithm is derived from the size of the message that it carries. And then the number of steps involved in each of the secure hash algorithm is for secure hash algorithm 1 is 80, the other one is 64, the other 2 is 80, and then the number of words we have 32 word size. 32, we have 64, and then we have the number of blocks for the last 2 is 10, 24, and 20, 10, 24. So the applications of secure hash algorithm is one, secure password hashing, and then we have secure socket layer, the SSL security protocol for most of the websites. And then we have can be applied in digital signatures. And then these are some of the reference that you can check and learn more about cryptography, or not secure hash algorithm itself. So this one is actually complex to understand, but to understand and also let me just go back to what we did yesterday, and this one will make it a little easy to understand. It was me. Uh, yeah, this one. So as you can see, this is what I actually mean by the number of so these are different. Okay. Mm, just a minute. I hope you can see the other screen.
Yes, you can see it.
Because I have I have the browser and the PDF.
Yeah, yeah, we are seeing it too. The mnemonic and the comparison.
Yeah. So this is actually another form of encryption, but it normally it works the same as this one BIP 39. It's just another form of encryption. Yeah. So this is the reason why most of the words have like 12 words. If you have less than the word has low entropy and may be guessed by an attacker. So the more words or the size of words the secure hash algorithm handles, uh, the better the encryption technique, and the better it becomes, or the hard it becomes for the hacker to actually hack. So if so with this you can actually be able to like see the with this one, if you are creating, so you see this is the heads value that I was talking about. That is the number of heads. We have different heads decimals. We have octo and we have octo we have octo and octodecimal and hexadecimal. So octo and hexadecimal are numbered in bases. That is the octal number of is of base 8. We have the one which actually represent eight numbers, so it's from 0 to 7 to represent the numbers. And then heads we have the other one which heads and it's one for 16 numbers. It's hexadecimal, which is base 16. Yeah, so octo and hexa, which is base 16. These are some, if you have done something to do with such, you will be able to understand this computational math. This one. Yeah, this one. So you can be able to understand. Yeah. And then yeah, so here you can be able to see the kind of and so with hexadecimal you are able to kind of come up with a good secure algorithm, with a good secure hash algorithm that normally used for private keys. So this form of encryption, BIP39, is normally used for wallets, and it's a asymmetric form of encryption. Yeah. So you can also see. So you can also see the use the mnemonic length, which is 3 words per 32 bits, from this part. Yeah, from this part. So it's 32 bits per it's 3 words per 32 bits. So means that, you see, from here, if we count, we have 12 words. 1, 2, 3, 4. Not that one. Those are not the words. Let me just reload it, and then so that we have 12 words, then generate. Okay, yeah. So we have these words, 3 words per 32 bits. So if we count, you only have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in reality, we have more than 12 words, because they are spaces. They are spaces. So these spaces, if we remove these spaces, if we try and remove these spaces, this will be different. This will be a different encryption. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. But there is a way they for it to be human readable form. Yeah. And then if you change it to base 10, that is base 10 of the binary code, binary decimals, or binary number, which starts from 0 to 9, then you see the words actually change. The words actually change, and it starts, it only has three words. The same case for that one. So if these ones are invalid, these two are invalid. So 0 to 1 or 0 to 5. So if 0 to 5 actually applies to the one-time passwords, the one-time password. But for wallets, heads a decimal code, or it's the one which is preferred. Yeah, and then this one is a bit complex. This one, yeah. So these are the number of, or the length of words. Yeah. So that's it about secure hash algorithm. They all work the same. So whether it's secure hash algorithm 1, 224 and 256 and 384 and 512. Yeah. Thought I had some a simpler way of like explaining without all this math. Yeah. So that's it about yeah. So if somebody has a question before we go or dive deep into we go to the other type of wallet. Yeah. Hello. 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 Does anybody has a question on secure hash?
No, I don't have any question.
Okay. Okay. And you, Damaris? Okay. Okay. So we can, yeah, it has a lot of math in it. So, yeah, so yesterday we also talked about web wallets and online wallets, and we said MetaMask is an example of a web wallet, and we have others. We have exchanges, wallets that are managed by exchanges, and one of the best thing about exchanges or exchange wallet is that it's easy to it's easy to complete transaction using online wallets. Then we talked about mobile wallets. And mobile wallets are the wallets that can be downloaded and installed into devices. And user can also be able to like protect your wallet from security lists. Some of the mobile wallets are like offline. A good example of an offline wallet that I know is that one of the Kotani Pay, which is a USSD managed platform wallet. It's actually uses USSD, so in such a way that you can be able to like use USSD to create an account and also withdraw from an online wallet onto your local M-Pesa wallet. Yeah, through that. And so another thing is that users can quickly scan the QR code from a mobile wallet and make payment. So basically they are more used for making payment and also managing assets. Then we have desktop wallets. So desktop wallets is a wallet that is more secure. It's a more secure way to store cryptocurrencies than a mobile wallet and online wallet. Still, users must make sure to provide ultimate security to Bitcoin wallets and Ethereum wallets. And desktop wallets are the best because they store Bitcoins in offline mode and provide more info on security. On security. So I had shown you one wallet that I have, uh, which is a which is a which is this one. So this one is a Zero wallet, which is a desktop wallet. There was another one that I had downloaded in the previous year. That was Atomic Wallet. So Atomic Wallet is also a desktop browser. You can use it to manage your assets. And then we have Mist browser. So these are some of the special consideration that you may need for your wallet, or to keep your wallet secure. And one of them is consider cryptocurrencies that the wallet, if you are choosing a wallet, so consider the types of cryptocurrencies that you want to hold, or that wallet holds. So there are currencies that have multiple assets, like Trust Wallet. Trust Wallet, I believe it holds multiple currencies. The same for Ethereum. I don't know whether not Ethereum, but MetaMask. But MetaMask does not hold Bitcoin. I haven't. Yeah, doesn't hold Bitcoin. The standing of the company, the place where that company is actually, whether it has developer, whether it has had recent hacks, whether the developers are keen to like update their system and their software, their wallet. Then again, the backup feature of the wallet. If the wallet does not have good backup features, then you need to like do a consideration on that. Then we have examples of wallets. We have Trezor One. So Trezor One is a hardware wallet, which you can like carry on your pocket using on your pocket. It's like a flash disk or something. And then we have MetaMask. We have Trust Wallet. Trust Wallet is a mobile wallet. Rejanano is a this one, Lejanano. I've never actually seen Lejanano. Yeah, it's also a hardware. It's also a hardware wallet. Yeah, yeah. They are similar to Trezor. And then we have Exodus, and then we have Mist. So Mist, this one Mist, I've actually shown you how it looks like. I'll show you how it looks like. It's a it has combination. It has sorry, browser. It's a wallet, and at the same time it's a way that you can use Mist browser to create, and also uh to create. Don't know whether they changed, but there was a way you could actually use Meta Mist to do your creation and also your local development using Mist. So it's a browser for accessing the accessing P2P, and also accessing dApps. Then we have Exodus. This is how Exodus looks like. Wallet, Exodus wallet. It's also a desktop wallet, and yeah, so you can actually look at uh, the different the different types of currencies the wallet holds. So as you can see, Exodus has 100 plus cryptocurrencies. So it supports Bitcoin, Ethereum, Doge, EOS, Dash. Yeah. So those are the some of the things that you also need to look at, and I think they uh, actually had a release of their mobile wallet. Yeah. So to avoid like having a lot of wallet on your system, you do the three consideration that I've mentioned, because you may find yourself installing all wallets or buying hardware wallets, but they are not supporting your needs. They are not supporting your needs. Yeah. So that is it about wallets. I think for the wallets, we have come to an end of the wallets. We have come to an end of the wallets. So something that I've not spoken about is the difference between hot wallet and cold wallet. So hot wallet versus cold wallet, the only significant difference between hot wallet and cold wallet is whether the wallet is connected to the internet or not connected. So hot wallets are the wallets that are required to be connected to the internet. And because of this, these wallets are less secure. These wallets are highly accessible because of the internet, but these wallets are are also vulnerable to security threats and attacks by fraudsters. So hot wallets are more user friendly, and there is always a risk to user security and privacy. So, well, cold wallets. On cold wallets, we cold wallets are the types of cryptocurrency wallets for cold storage. Most of these wallets are the examples that I've given. That is Ledger Nano and Trezor, because they are hardware wallets, and also desktop wallets. Some of the desktop wallets. And these wallets store crypto tokens in offline mode and provide improved security. Cold wallets are always a safe option than other wallets, because these act as a vault of carrying and out daily transaction. So these are different types of wallets, from which some are connected to the internet, while some are not, and users must choose the wallet according to their need. So you have to choose your wallet according to your needs. I've actually mentioned some of the considerations. So when you want to acquire cryptocurrency, whether by purchasing it in a currency exchange or receiving it as a gift or as revenue, you direct the sender to a unique cryptographic address issued by the wallet. You might picture your cryptocurrency stored on the wallet the same way files are stored in a USB drive, but in fact, the information stored on the wallet only points to your cache location on the blockchain. So the public ledger that records the authenticate and authenticates all transaction for cryptocurrency. So spending with wallet is as simple as scanning the retail glass QR code, or directing a specific amount of crypto coins to retailer public address. So that's how wallet works. And yeah, so also different wallets have different supports of like for MetaMask, you can buy coins, and then you can buy coins, and then these coins are deposited into your. You can buy coins from. Sorry. You can buy coins from. Yeah. So if you click on buy, you can buy coins from buy ETH with wire, or buy directly from a direct deposit ETH. If you have already some ETH, the quickest way is to get ETH in your new wallet by depositing it. So there is also in sometimes back you could also buy ETH. MetaMask was supporting Coinbase, but right now I don't see if they are supporting Coinbase. So depending with how you want to buy your coin, you have to check whether they support payments or channels that can be able, like Visa card. If they do support Visa card, if they do support Visa card, uh, if they do support Visa card while you are buying, if the type of exchanges or the type of buying platforms that you can be able to use. Yeah, if it is for swap, if they have a swap where you can check. So depending with what you are using, depending with what you want, all your intentions of the wallet you want to, you have to, those are some of the considerations that you need to take a look at. Yeah. So that's it about wallets. So tomorrow we will check about we'll check excuse. Yeah. So those are some of the consideration that you need to take when you want to install a wallet in your phone or your browser or your. And also, if you are a developer, you also need a wallet that supports developer tools and supports your development. If you want to interact with other with other networks, yeah. So that's it. If so, tomorrow, like I was saying, tomorrow we will cover the differences and the differences of cryptography and yeah, we will learn more about cryptography and yeah, I'll try and simplify these mathematical expressions. Try and yeah, if that's okay. And also I'll upload this one because these two PowerPoints are not available on the, so this one and the other one are not available. Yeah. So if somebody has a question, yeah, you can go ahead and ask.
Hello.
Hello.
Yeah, but currently in the cryptocurrency or cryptographic encryption,
Mhm.
the most used is the secure hash algorithm 256, correct?
Yeah, yeah.
Because I can see 2512, I mean 512 and 384. Are they for the future or they are not as secured as 256?
They are secure. They are secure, but it depends with the application or the applications that you are building. Uh, let me let me show you. It depends with the applications that you are building. It depends with the application you are building. And this one, so this one, to 5 seats, 5 seats is a bit faster in terms of processing. When this other one is also quite, it's quite quite slow. But it's also depend with the kind of system that you are creating, because we have encryptions that, the TLS certificate and socket secure socket layer for web encryption, or the digital certificates that are created for domain hosting. So yeah. So one thing for another reason is that secure hash 256 outputs are very short, which actually saves the bandwidth of what you are sending. And then the secure 512 favors is used in different hardwares for different function, and it's also used on OpenSSL certificates, because it's a bit longer. I don't know if I have a cPanel so that I can be able to like show you. Let me see if I can be able to log into my cPanel. cPanel, cPanel. Yeah, and I can, so that I can be able to show you the. This one mainly applies in webs for web certificates. It's like a big document. SSL. Yeah, this one SSL. So these are the RSA, the ESDSA. These are also encryption methods, and so we can let me just view the certificate of one of my certificates of these websites. So this is the that one that I was talking about. See, it's quite long, it's quite big, and now imagine this being used for our private key. Well, this one will be to actually for human, it would be a lot of work. You see, so it depends. Yeah, so it depends with the kind of application you are building, or the where you are applying this code, this the the application that you are building. It normally is a price for that. Yeah, it applies to that. Yeah, because if you can see this message, this is now the message that we were talking about, the length of it. It has a lot of information. This particular code has a lot of information about this entire site and entire website, all domain. Yeah, and it certifies that this is my. So if somebody else steals this certificate, they can be able to claim. They can be able to claim the site or something. They can change a lot about this site. Yeah. So tomorrow we will look on the various things that are the the things that are actually are the things that you need to consider while creating a system using cryptography, or the things that you need to put into consideration so that you come up with a secure system. And some of the reason some of the things on why attackers are able to like bypass different cryptographic algorithms. Yeah. And one of them is one of the reason is that one, sometimes the users are negligent. They store the private key bad. So yeah. And then we have something like brute force attack. It's the BFAT. So brute force attack is we will learn about it tomorrow and see how you can kind of use it in that. So I'm not a hacker myself. I'm not a hacker. I'm just a programmer. So I can't hack your system. Yeah. So yeah. So this is the wallet that I was talking about, and this is a desktop wallet, and you have the same features and everything. So I don't want to log in. Yeah. So any other question? Hello. Damaris, do you have a question, comment?
No, I don't have a question.
Okay. Yeah. So that's it about certificates. So the one for 215, and the other one is actually for digital certificates in websites. Yeah. So that's it on cryptography and wallet. So for wallet there was for wallet it didn't have a lot of details, because this one we will actually, yeah. And then on this PDF, this one for introduction to blockchain ADS final. After every lesson, there is some assignment. Yeah, after every lesson we have some assignment. Yeah, yeah. So yeah. So let's meet again tomorrow, same time. Yeah. Thank you, and good night. And yeah,
All right.
enjoy
Thank
the
you
rest
very
of your
much.
evening. Yeah.
Yeah, good night. And you too.